Okay. Good morning, everyone. Am I audible?
अब बोल सकते हो।
Okay, just wait 1 minute, then start. Okay, so let's start. So we have discussed in last classes different types of control systems. Okay, so we have to firstly classify it into two categories. First one, that is the open loop control system, and another one is the closed loop control system. Okay, and also another topics we have to learn, that is feedback systems. Okay, so this feedback all of you learn. So this feedback, it is also classified into two categories. First one, that is a positive feedback, another one is a negative feedback. So just I am recall just shortly and then continue. So this feedback, so what is the feedback system? So we have to consider that is two control system, that is open loop control system and closed loop control system. So in this closed loop control system, we have to attach one, that is a feedback loop systems. Okay, so this feedback loop we have to attach according to the output and input terminal also. So this process of taking okay, so let's start. So we have discussed in last classes, that is feedback systems. Okay, so this feedback, it is also attached in this closed loop control system. We have to discuss this open loop control system and closed loop control system. So in this closed loop control system, we have to attach one another part, that is feedback loops, that is feedback system. So any process or plant that is taking a fraction of output signals and it is feeding it back to the input circuit, it is known as the feedback loop. So this feedback system or feedback loop, it is attachable in the output signal and the corresponding to the input signals. Okay, so according to this format, in our system, this feedback system, we have to classify it into two categories. One is the positive feedback system, another one is the negative feedback system. So in the positive feedback systems, so here voltage or current, it is in the present on the phase with the input signal. Okay, and it is also known as the positive feedback systems. And if the feedback system, that is a feedback input voltage or current, it is out of the 180 degree of the phase angle. Okay, so out of the phase, that is the one over the 180 degree phase angle, some this time it is also decrease the input signal and the amplifying the signal of the input. So then it is called the negative feedback system. So I just recall one thing again. So when the feedback voltage or current, it is in the present, that is the in of the input in the towards the 180 degree in the phase of the input signal, this signal, it is, or this feedback system, it is called the positive feedback system. And in the negative feedback system, in the feedback voltage or current, it is out of the 180 degree of the phase angle, and in that time input signal, it is decreases the amplifier input, then it is called the negative feedback system. So these are the basically difference between the positive feedback and negative feedback system we have learned. So in the positive feedback system, it is in the present on the phase angle, input of the phase angle, it is to the 180 degree. But in the negative feedback system, it is out of the phase, that is the over of the 180 degree of input signals. Okay, next, this positive feedback system, it is also regenerative feedback system. Okay, but in the negative feedback, it is also degenerative feedback system. So in the positive feedback system, it is also we have to increases the net input of the amplifier signal. Okay, so these are the basically input signal, that is input voltage, sorry, that is input voltage we have to implement, that is Vi, that is also Vs plus Va. This Vs, that is the source voltage, that is positive region, this is the feedback voltage. But in the negative feedback system, it reduces the net input to the amplifier section. This is input voltage, that is Vi, that is equal to source voltage minus feedback voltage. This is called the negative feedback system. Okay, so in the control system, in positive feedback system, the gain of the amplifier section, it is increases in the positive feedback systems. Okay, but in the negative feedback system, the gain of the amplifier section, it is also reduces. Okay, and also positive feedback system, it increases the noise level or distortion level. But in the advantages of the negative feedback system, it reduces the noise level or any types of distortion is present in the controlling actions or controlling variables. This is the advantages over the positive feedback systems. Number 6, this positive feedback system, it decreases the stability of the amplifier gain. Okay, this amplifier gain, what is the gain? Gain is the ratio between the input variable to the, sorry, output variable to the input variable. That is gain equal to output by input. Okay, so in the positive feedback system, it decreases the stability of the amplifier gain also. But in the negative feedback system, it improves the stability of the amplifier gain also. So these are the basically advantages, these 2 points over the positive feedback systems. And this positive feedback system, it is uses in the oscillator circuit. Oscillator circuit, that means you have to, all of you seen the cathode ray oscilloscope device. In this cathode ray oscilloscope device, we have to design the different types of oscillator circuit, that is sinusoidal wave, rectangular wave, different types of waveform we have to design. So this positive feedback, it is uses in this oscillator circuit. Okay, and when this signal it is amplified or amplifying the signal, these negative feedback systems we have to use this in the amplifier circuits. So these are the basic main properties or main characteristics of the one is a positive feedback, another one is a negative feedback systems. Okay, it is clear, all of you? Anyone any doubts? So please ask me. Okay, so we can go next. Next, we have to discuss that is a mathematical model of the different types of system. So first, we have to observe the transfer function of a given controlling actions. So this transfer function is one of the way to model a system is mathematically. When a physical system it is analyzed, and mathematical model it is developed by the writing differential equations with the help of the various physical laws governing the systems also. So you have to given one block diagram. That is block diagram, that means we have to see in the previous lectures, that is a closed loop systems. So closed loop system, at the first time you have to given the input, then you have to given the set point or reference point, then you have to select the process of plan, something like that. These pictures, just you have to follow this picture. This is the closed loop system. Okay, so you have to select the reference input from here, and this reference input we have to denote here, that is RT with respect to the timing. This reference input we have to given one selected, that is a set point. This is called the set point or reference point. This is also sometimes it is also called that is error detector. And this set point, it is also given the signals, that is a control element, that is a controller. This is called the controller actions. So here you can see this is called the controller part. Okay, then after this controller part, it is given the signal, that is plant or process, that is industries. Okay, so this controlling actions, that is a controlling signal, it is given the process or plant. Then this process or plan, it is processed, the given the input from the controller part. Then finally you have to given the output, that is a controlled output. Okay, and again this output section, it is also attachable one feedback loop or feedback path into the corresponding input sections to the this set point or multi point. Okay, or reference point. So this is a feedback signal, that is the direction. This is the feedback signal, we have to denote it here BT, and output, that is a control output, that is a CT. So first we have to given this block diagram. So this, according to given this block diagram, we have to design first transfer function. So in this transfer function, we have to use different types of block or different types of loops or different types of set point, something like that, input variable, output variable, according to the given format. So in this transfer function, it is a mathematical expression of the given desired input signals, and you have to implement these functions according to physical system in the analyzed and mathematical model. It is developed by the writing differential equations with the help of the various physical laws applied governing the system. So most of the control system, it consists of the electrical or mechanical equipment also. Okay, so that is some examples. That is, you have to operate the water pump or water pump controller system. So this is a one desired systems. You have to select the input variables. You have to first switch on the motor. The motor is first, the alternator is working. Then this is motor, it is rotating prime mover using the prime mover system. So alternative by using the help of alternating system alternator. Then the motor it is working. Then the water it is also output, you have to given this water is filled to the tank system. And when a system, we have to attach the closed loop system. When the tank is filled by the water, then one signal it is given according to the feedback loop to the reference or input or set point variable. Then the motor it is stopped. Then this process is continuing. Okay, so this is basically one example when we have to observe this physical system or analyze the mathematical model by using the different types of differential equations. So this transfer function, it is very helpful concept in modeling the interaction of the subsystems of forming the different types of block diagram also. Okay, so this transfer function of linear time invariant system. So sometimes it is also called that is LTI system. This LTI system, that means the linear time invariant system, that is transfer function. It is defined as the ratio of the Laplace transform of the output to the Laplace transform of the input under the assumption that initial condition are to be zero. Okay, so this point it is all of you note down it. What is LTI system in a given transfer function? So transfer function of linear time invariant system or LTI system, it is defined. It is the ratio between the Laplace transform of output variable to the Laplace transform of the input under the assumption that initial condition are to be zero. So this is called the LTI system. Okay, so in the corresponding, when we have to write the LTI system, that is a transfer function we have to design. So we have to follow the different types of rules. Okay, just wait. So first we have to write the differential equation of governing to the given transfer function or signal. So first we have to write the differential equations. First we have, sorry. First, we have to write the differential equation governing these systems also. Then, number two, find the Laplace transform, that is a replace the different terms. Okay. First, we have to observe that the input and then also output also. So this is del t or d dt. So sometimes we have to write del t or d dt. It is replaced by the Laplace transform, that is f. And also integration of del t, we have to replace these terms in the Laplace transform, that is 1 by s. So please remember these two things also. Then number three, that is find the ratio of transformed output to input variables. That is the gain also. We have to tell what is the gain. That is transfer function ratio. It is ratio between the output to the input variable. Whatever you have to receive the output from the output variable corresponding to the input variable, this is the ratio between the output by input. It is called the transfer functions. Okay. First, we have to control, that is impulse response. Just wait, I am using my whiteboard, then I have to continue. Okay, sorry for the interaction. The whiteboard is disturbed today. Okay, so first we have to follow these three rules. I think it is clear. So first we have to discuss that is impulse response. Okay, so this impulse response, it is defined the output when the input is unit impulse functions. Okay, so we have to apply these RC circuits. So here you can see this is a input sections of any input variables, that is input voltage. Then it is also output voltage, that is VOT, we have to denote it here. This is the resistors we have to represent, that is R, and also capacitor, that is RC circuits. Okay, so in this response, impulse response, it is defined as the output when the input it is unit impulse functions also. So the Laplace transform, we have to apply the impulse response, that is a transfer function with its all initial condition assumed to be, we have to 0, because we have to learn here, because you have to follow these three rules also. Okay, first we have to 0 the LTI system in the linear time invariant system. We have to assume the initial condition to be 0. So here the two things we have to deserve, that is one is the input section, another one is the output sections also. So we have to easily write, that is input function, that is the input voltage VIT, that is equal to ITR plus 1 by C integration IT dt. Okay, according to these RC circuits also. And what is the given output result from the output sections? That is corresponding to the capacitor. So VOT, that is the output voltage. This is equal to 1 by C integration IT dt. Okay, so now we have to apply the Laplace transform in the input section and as well as also output response. So the input response, that is we have to change it, that is S, we have to learn in previous rules. So VIS, this is equal to ISR plus, this is also changes, that is IS by CS. Okay, so this is the Laplace transform of the input voltage from the RC circuit. Then we have to easily accommodate this equation, that is VIS, that is equal to, this is the common factor of IS, this IS, the IS, that is R plus 1 by CS. So we have to input voltage apply according to the Laplace transform of the input circuit here. Then we have to easily write the output voltage. So this output voltage VOT, we have to apply the Laplace transform in the input output voltage. So we have to write, that is V output voltage is, that is equal to, we have to write IS by CS. Okay, so now we have to calculate, that is input voltage and output voltage after the Laplace transform of given circuits or impulse response circuits. So now we have to calculate the gain or the ratio of the transfer functions. So what is the gain? We have to tell, that is output by input. So we have to easily write output, that is a V output S divided by V input S, that is output by input. So you have to put it the value from here, that is output IS by CS, and then input, that is a IS into R plus 1 by CS. So here this IS cutting, and then CS it is also cutting, that is required equation, that is 1 by 1 plus RCS. So this is the output equations of the impulse response of these RC circuits. Okay, and also it is called the transfer function, that is TF. Okay, it is clear all of you? Sometimes this model, this type of model, given mathematical problem, it is also coming in your exam. That is, derive the circuit, that is RC circuit, into the transfer function, or derive the transfer function of given circuit. This type of question is also coming. Derive the transfer functions of the given circuit. So at that time you have to given this circuit, you have to easily input and output calculations, then you have to ratio between the output by input, then you have to easily calculate the transfer function of the given circuit. Next, another one, this is RLC circuit. Here you can see this is the input variable or input voltage, and this is the output voltage. So now this is the R, L, and C. So the output, it is considered according to the capacitance also, and input it is also present, that is a resistance or load also. So we have to easily written this equation, that is the input position, that is input voltage, that is EIT with respect to the time, that is ITR according to these are the current directions. This is ITR plus, that is LDIDT corresponding to the timing changes according to the load, plus that is 1 by C integration ITD. Okay, so we have to easily write from this RLC circuit. Then we have to apply the Laplace transform in the given input signals. So we have to easily write EIS, that is equal to RIS plus, that is ISCS plus 1 by C IS by S. Okay, this is IS LS, that is a L for the inductor coil. Okay, so next line, this is the common part IS, the IS common part here, ISO IS and also IS common part. So we can easily common this part, that is IS equal to R plus LS by 1 by CS. Clear? So this is the input equation after the Laplace transform of the given circuit, that is the RLC circuit. Clear? It is clear, all of you? Please respond anyone.
Yes,
it is yes, yes. And next, now we have to consider the output voltage according the corresponding to the capacitance also. This is the capacitance. Okay, just wait 1 minute and continue. Okay, so we can easily apply, that is the Laplace transform in the output sections, that is the output operations. Okay, so output equation, that is EOT, we have to denote it here, that is equal to 1 by C according to the capacitor integration ITD. So you can easily apply the Laplace transform in the output equations. So we have to write, that is EOS, that is IS by CS. So now we have to calculate, after the apply the Laplace transform in the given RLC circuit, that is input circuit, input operations, that is the output operation. So this is the ratio between transfer function ratio, that is the output by input, that is E output by E input. So you can easily inputted this value, that is IS by CS by IS into R plus LS plus 1 by C. You have to calculate this one, then this IS neglected, CS is neglected, the equation that is 1 by S squared LC plus RCS plus 1. So this is the required transfer functions of the RLC circuit after you have to apply the Laplace transforms also. So this type of mathematical model, it is very, very important for your exams questions also. Okay. It is clear, all of you?
Yes, sir.
Okay. So now we can go another examples. This is another one. This is also RLC circuit also, but the position it is also changes. So here input voltage it is also applied according to the load, that is the inductor coils, and capacitor and resistance it is also changeable here also. So now you have to easily you have to apply the rules of the Laplace transform in this circuit. So the input voltage, that is the input terms, VI you have to denote it here, output of the with respect to the time here also. So first we have to calculate the input equations, that is VIT. So this is corresponding to the inductor coil, that is L di dt plus 1 by C integration of IT dt plus ITR. Okay. So this is the input equation before applying the Laplace transform of the given circuit. So after Laplace transform, it is changes, that is a VIS, that is equal to LIS plus 1 by C IS by S and also RIS. Clear? So in this circuit, this is the one common terms, that is a IS. So after IS is common, that is LS plus 1 by CS plus R also. So this is the input equations after the Laplace transformations. Now we have to consider the output also corresponding to the resistors, because this is a parallelly connected to the output equations. So the output VOT, that is equal to ITR. Okay, so this ITR, that is we have to apply the Laplace transform the output equations also. So we have to easily write V output, that is according to S equal to RIS. Okay, so we have calculated the input equations, the input terms also, and also output equation after the Laplace transform. So you can easily apply the rules, that is gain, that is a transfer function, that is equal to output by input, that is V output S by V input S, that is equal to, we have to easily inputted the value here also, that is RIS divided by this one IS equal to, that is a, you have to easily calculate it here, and then the finally we have to result is coming, this IS and IS also cutting, that is RCS. Okay, RCS or SRC, that is by S square LC plus RCS plus 1. So this is the complete transfer function equation of the given circuits, that is the LCR circuits. And so on. So there are lots of examples are present. Okay. So just last one we have to reserve. So we have to given this type of model circuit. This is called the mathematical model of different circuits, RLC circuit, RC circuit, or different given network circuits also. So here you can see this is another complex circuits we have to design, that is two register circuit, that is R1 and R2. This is the first network, that is R1 and C1. This is the capacitor C1. This is the capacitor C2. This is the first network circuit. This is a second network circuit. Finally, we have to given the input the given. Then finally, you have to receive the output from the here. So you can easily input it. So you apply the Laplace transform in this given network circuit. So first, that is a VIT, that is equal to I1 T R1 plus, that is corresponding to the 1 by C integration I1t minus I2t dt. Okay, so because these are the another network also, is it? So we have to apply the Laplace transform in the given network circuit. So VIS, that is also R1 I1S plus I1S by CS V1S plus minus I2S by V1S. Okay, so these are the basically first we have to apply the Laplace transform in the given network circuit. Then we have to apply the KVL rules, KVL law in the second loop. This is the second loop also. So we have to apply the equations. So the equation is coming 1 by C1 integration of ITP minus I1 T dt.
Yes, sir.
Recording in progress.
So you have to take one.
So please repeat, sir.
So you have to take one screenshot, okay, the participant list, and then finally you have to send me after the ending the class. Okay.
Attendance, no, sir.
Yes, attendance.
Okay, sir.